we're live. Two consecutive integers such that the sum of, find two consecutive integers. I bet you've seen problems like this before. Anyone? So when you have a word problem, you really need to set up your variable first. Set up your variables. So two consecutive integers. So if what you do is you let x equal the first integer. Okay? Let x equal the first integer. Okay? If they're what does consecutive mean? Can you tell me three consecutive integers, Ian? No? How about 1, 2, 3? How about 7, 8, 9? Right, 7, 8, 9. Yeah, he was hungry, right? But 3, so the first integer is x, okay? So if x is the first integer, what would be the next integer after that in terms of x? Who said that? Oh, Jessica. I was hoping it was someone else. No, not because we don't like Jessica. But, yes, the next integer would be x plus 1 is equal to the next. Okay? Integer, right? Because integers go up, if they're consecutive, they go up one at a time. If they're like consecutive odd integers, then they go up by 2s. Consecutive even integers would go up by 2. And so find two such that the sum of their squares is 365. Anyone think they could tell me what that equation looks like? How would I write the square of x? X squared, right? So x, how would I write the square of x plus 1? X plus 1 squared. X plus 1 in parentheses squared is equal to, sum of their squares is equal to 365. You get it? Okay? That's how you set up the equation. Now you got to solve the equation. Anyone have any ideas? What do I have to do with this? What's x plus 1 squared? You have to FOIL it out if you don't know how to, if you don't know the shortcut, right? This means this, which is x squared plus x plus x plus 1. So you have x squared plus x plus 1 equals 365. You guys with me there? Yeah, I foiled that. I'm going to take a picture of this and bring it to a bigger page. So far I have this, okay? And I need to combine my like terms. So this and this go together, and this go together. So I get 2x squared plus 2x plus 1 equals 365. This is kind of similar to the warm-up. What do I need to do before I solve? Subtract 365, right? So 2x squared plus 2x minus 364, right? Because if I subtract 365 from both sides, equals 0. Wait, I subtracted 365 from both sides. Okay? Subtract 365 from both sides. Any idea what I do next? What number goes into 2x, and 364? 2. So what I would do is divide away a 2 first, because then it's going to be easier to factor. X squared plus x minus 182? Negative 182, I believe, equals 0. Okay? So now what you have to do is factor this part. Think of two numbers that multiply to 182 negative and add to what? 1. So those two numbers can only be 1 apart. Right? I don't know what they are. You know what they are? Well, they're consecutive integers, right? So they have to be just 1 apart. So just guess and check. What's 12 times 12? 144. So it's got to be bigger than 12, right? What's 12 times 13? It's got to end in 6, so that couldn't be it. You understand? Kind of. So then I tried. So I said 12 times. This is what I did. I said 12 times 12 is 144. That's too small. I said 12 times 13. That's going to end in 6, so that couldn't be it. And then I said, how about 13 times 14? Because then I think I'm getting close. So is 13 times 14 182?
Yeah.
Yes, it is. Okay. So one of them has got to be positive and one of them has got to be negative. Since this is a positive one, then the 14 has got to be the positive, and this has got to be the negative. Okay. And then so you write 2 times x minus 13 times x plus 14. So either my integers are x, what do I get here for x? What will make this expression equal 0? 13. Or x is equal to negative 14. Is this a positive integer? Could this be it? Because I think our original problem, didn't it say they have to be positive integers? Find 2? No, I guess not. Okay, so the numbers could either be, so going back, I have 2 possible answers. One answer, if x is 13, what's x plus 1? 14. If x is negative 14, what's x plus 1? Negative 13. Very good. Who said that? Chase? Oh. Thanks, Jay. Okay, so this is your answer, or this is, both of those are okay answers. Because if I square them and add them together, I get 365 in both cases. And an integer can be positive or negative number. Do you think you can do that on a test?
Yeah.
That'd be kind of challenging. There's a lot of steps.
What is this called, though? Like, what will it ask us to do on a test?
It'll say something, find 2 consecutive integers whose sum of the squares is, it's a word problem.
So this would be a word problem.
This would be a word. Yes, sir. That's an excellent question. Go ahead. Okay. Yes, Adam.
What do we do with the 2? Like, does it just stay there?
Yeah, the 2 doesn't matter because I could divide it away, right? I could divide both sides by 2, and the 2 goes away, right? So the 2 doesn't really matter because you're just trying to determine what's going to make this expression equal to 0. You know? So that's right. Oh, look, 6 minutes. Should we do the next one? Please, please. Okay, what's the next one say? A photo. Oh, these are the same thing. I don't know if I'll go through all these. Maybe I'll let you work on 1 or 2. Okay? So, partial. A photo is 3 centimeters longer than. Uh-oh. What happened? This stop? No. It's still going. A photo is 3 centimeters longer than it is wide. Find the length and width if its area is 108. Okay? So what I would do, I would draw a picture. Okay? And we call the, if this is x and it's 3 centimeters longer than it is wide, what's this side? X plus 3. How do I find the area of something? Multiply. Okay, so x times x plus 3 equals 108. That's not that hard to set up, is it? But this one, again, you can't just say use guess and check or anything. I guess you could use guess and check, but that's kind of cheating. You really want to solve it algebraically. So to solve it algebraically, first you need to distribute this x through. So x times x makes x squared. X times 3 makes 3x equals 108. Now what do I need to do? Subtract the 108 from both sides. Okay, so I'm going to subtract 108, subtract 108, and I get x squared plus 3x minus 108 equals 0. And now I gotta find two numbers that multiply to negative 108 and add to 3. You guys tell me what those numbers are. Go ahead. She's right. Negative 9 and positive negative 9 and positive 12. So that means that this factors to x minus 9 times x plus 12 equals 0. What's this side length? X equals 9 or x equals? Can you have a side length of negative 12? Can you have it? No. So in that case, you could throw away this answer because you can't have a negative side length. So if one side is 9, what's this side over here? 12. Okay? So that's kind of where the negative 12 comes from, but it can't be negative, it's got to be positive. That one's not that bad, was it? Was that one bad, David? Not too bad? Okay. We're moving on. Oh, wait! Okay. Let's move on to the guard. Oh, you're not going to like this one. Maybe not. A guard. So these ones, I've seen these a million times, these types of problems. And you should kind of know how to do it because it's kind of hard because they come up a lot. A gardener has a rose garden that measures 30 by 20 feet. He wants to put a uniform border of pine bark around the outside of the garden. Find how wide the border should be if he has enough pine bark to cover 336 feet. So what you have here is you have a garden, and then you have another garden surrounding that garden, kind of like, let's see if I can get it a little better. Let me see if I can move this so it looks like, man, that's not so good. You have a garden within a garden, okay? And this dimension is 30 by 20, okay? And this dimension on all sides is x, from here to here, and from here to here is x. I know it looks different, but I tried to do as well as I could, and this is x. All right? And what you have to do is figure out, they'll find how wide the border should be if he has enough pine bark to cover 336 feet. So in other words, the pine bark is going to be in this shaded area over here. So they tell you that the area of the green, okay, the green area of green is 336. But how can I find an algebraic? Can anyone come up with an algebraic expression that would give you the area of the green part? Go ahead. Go ahead, Jessica.
You calculate like the area of the total rectangle minus the
Exactly.
area.
Okay. So it'll be the area of the outside rectangle minus the area of the inside rectangle. Do you understand that? Okay. How would I calculate? If this is 20, what is this dimension from here to here? If this is x and this is x and this piece is 20, what's that dimension right there in terms of x?
20x.
Not 20x. 20 plus 1x and 1x is 2x, right? 20 plus 2x. What's this dimension from here to here? If this is 30 and each of these sides is x, what's that? Who whispered that? I heard someone whisper that. Is that you, Netta? What is it, Andy? 30 plus 2x. Okay? So now the total area is going to be 30 plus 2x times 20 plus 2x minus the middle area, which is 30 times 20. 30 times 20, right? Because that would be the area of this. And that total area you want to be 336. This is a toughie. Okay? So I'm going to kind of go through this. I'm going to FOIL this out. This times this gives you 600. I wrote 300. I meant to write 600. Done. 600. This times this gives you 40x. This times this, what's 30 times 2x? 60x plus 60x. And what's 2x times 2x? 2x times 2x. 4x squared. Good. Okay? Minus 600 equals 336. That's your big equation. But it's nice because some things kind of combine and disappear. What could I cross out? Who said 600? You said that right. Okay? There's a plus 600, minus 600. You could get rid of those. I could take the 4x squared, put it in front. Okay? I can add together my 40x and 60x and get 100x. And I could take away 336 from both sides, right? And make that minus 336 equals 0. So now I have a nice quadratic equation. Anyone see something I can do relatively easy with that quadratic equation? Other than Jessica? Okay. Mandy. Very nice. Okay, so if you see something in front of the x squared, always try to make it disappear. So what Mandy said is factor out the 4, x squared plus 25x. How many times does 4 go into 336? 80 something? What is it? 84 equals 0. So again, you get one of these factoring problems. Two numbers that multiply to negative 84 and add to 25. I might have to do some guessing and checking there. 20 and 4? No. 21 and 5? 21 and 5? No. Just what? You guys tell me. 22 times 4? No. Yes, sir.
Is it 21 and 4?
Yes.
Negative 21.
Yes, it is. It's positive 21 and negative 4. Very good, Calvin. Okay? See? Teacher couldn't even get it. You got it. You're smarter than me. So now all you have to do is go x plus 21 and x minus 4 equals 0. Yes, ma'am.
Mr. Leader, 21 minus 4 is 25.
Oh, crap. Should I just calculate? Oh. Calvin, what are you giving me the wrong answers for? Okay, so okay, so let's try again. Did you find it?
Right.
16 and
28 and -3.
that's correct. Okay. 28. So this one involves a lot of guessing. 28 and -3. That works. Okay. And so let's just change those. 28 and -3. That was a good try though, Calvin. I'm still giving you a point for that one. Okay. 28 and -3. Okay. And then I'm going to draw a little squiggly line. And I'm going to say either x equals -28 or x equals 3. Which one does it have to be?
3.
It's got to be positive 3. So if one side, so x is 3, but that doesn't really answer the question, because the question says find how wide the border should be if he has enough bark. How wide should the border be? Oh, that is the answer to the question. How wide should the border be? 3 feet or 3 centimeters or what is it?
What do you
feet.
do with the 4 that you factored out?
What?
What do you do with the 4?
It doesn't matter because I could divide away that 4. Okay. All I'm worried about is what numbers will make this equal to 0. Yes, ma'am.
What if you add in 3 to the equation that called plus 2?
Well, that's if they were asking you for the side length, but they're not. They're asking you how wide does the border need to be. So all you're really looking for is x. They don't say what are the outside dimensions. If they said what are the outside dimensions, then you have to go 20 plus 2x or something. Good. Okay. Do we have time for one more? What's the next one? I'm going to do number 4, and then, but I'm going to set it up for you or help you guys set it up, and then I'm going to let you guys kind of struggle through number 4. Okay? So, yeah, or at least try to do it. So number 4, do you guys know the Pythagorean theorem?
Yeah.
What does the Pythagorean theorem say? It says a squared plus b squared equals c squared. That's, you kind of need to know that to do this problem, okay? So the Pythagorean theorem, if you have a right triangle, let's make a right triangle. So, uh-oh. What happened? Get rid of that. So here's a right triangle. Okay? And Pythagorean theorem says that the sum of the squares of the hypotenuse is equal to the sum of the squares of the two sides is equal to the square of the hypotenuse. So a squared plus b squared equals c squared. Do you know that? Do you've seen that? Okay? So the length of the leg of a right triangle is 5. Okay? The length of the length of a leg. So a leg is the shorter side. Okay? The length of the other two sides are consecutive integers. Okay? Find the other two sides. Okay? So if I call this side over here x, what would this side have to be? If it's consecutive integer, x plus 1, right? Because they say the other two sides are consecutive integers. The hypotenuse is always the longest side in a right triangle. So now you could set up an equation. A is 5. 5 squared plus x squared is equal to, by itself, x plus 1 squared. Okay? So I'm going to give you guys some time to try to do this. FOIL this out, bring everything onto one side, and then try to factor it. Okay? Go ahead. Give it a shot. Right? I'll get back there. I'm just one. Okay? You have, what's 5 squared? 25, right? That's easy. Plus x squared. When I FOIL this, you get x squared plus 2x plus 1, right? Did any of you try to get all the x squared by itself? You should have. When you get all the x squared by themselves, look what happens. This goes away. Minus x squared, right? So that goes away from there and away from there. And I'm left with 25 equals 2x plus 1. Well, we solved these first semester. What do I do with that? How do I solve that? Man, no, here. How do I get rid of the 1? Subtract 1, subtract 1. I get 2x equals 24. What's x? What's x? 2x equals 12. What's x plus 1? 13. So those are the sides, 13 and 12. Notice that it works. 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169, right? Right? It checks. So I would check just to make sure. And again, that's what's known as a Pythagorean triple. If a squared plus b squared is equal to c squared, and it works, and those are whole numbers, that's called the Pythagorean triple. Or when the Pythagoreans get up to bat, and they don't quite hit a home run, it's called the Pythagorean triple. You get it, Alan? All right. Okay, so I'm going to set up one more for you, because you will see one of these in your homework, and then you'll have some time to work. Okay? So in this one, this is kind of uses the properties of gravity. This is kind of a gravity problem. While hovering near, it uses this formula comes out of acceleration due to gravity. Anyone know what acceleration due to gravity is? Did you hear 32 feet per second? You know that?
9.8 meters per second.
9.8 meters per second squared. Do you know what that means?
For every
That-
second you fall.
For every second you fall, your speed increases by 32 feet per second. Right? So if you fall 1 foot or 1 second, you're going to fall 32 feet. If you fall for 2 seconds, then you're going to fall 32 plus, your speed's going to increase to 64 feet per second. So you're going to fall for 32 plus 64, 96 feet, and so on. Okay? Or no, that's your speed, 96 feet. Anyway, it doesn't matter. Okay? So I had the sunglasses after T, but that's what this formula uses. That's where it comes from. While hovering near the top of the park at 1,600 feet, a helicopter pilot accidentally drops his sunglasses. I found them, see? Right here. These look like helicopter pilot sunglasses, right? Yeah. Okay. I brought my props for this problem. Okay. When will the sunglasses hit the ground? So what will the height be? This is height, right? What will the height be when the sunglasses hit the ground? 0, right? So this is a very simple problem to set up. 0 equals negative 16t squared plus 1600. That's all you have to do, right? Do you know how to solve that? What would I do? What could I factor out from both of these?
16.
Negative 16. I would factor in negative 16, okay? I'm going to put the 0 on this side. I'm going to go negative 16 times t squared minus 100 equals 0. And again, yeah, like we were talking about, you don't have to worry about the negative 16 over here when you factor. You could just divide it away and it disappears. Okay, look, I'm going to divide both sides by negative 16 and I get this nice simple equation, t squared minus 100 equals 0. Okay? What two numbers multiply to negative 100 and add to 0? 10 and negative 10. Okay? And so you get t minus 10, t plus 10 equals 0. So you draw your little squiggly line. T equals 10. You can't have t equals negative 10 seconds. So you throw this one away. When will the sunglasses hit the ground? How many seconds? 10 seconds. Probably that's not right because that's ignoring wind resistance, you know. And sunglasses, they hit like terminal velocity and slow down at some point, you know. They wouldn't just, they'd catch a lot of wind, you know. But if you dropped a rock, or I'm not sure. Okay, so that's the end.